Try this again. I've got two distributors to compare now. This is the one courtesy of Jeff. We're going to check that one out. Here's my original one. I'm going to try to get this all in frame a little better than I did last time. I have my hands in the way. So I've got it hooked up. I've got it on the what I call the low output side. This is the 60 degree slots. I'm going to turn it fast first so to simulate actual running in the car. Those are about 20 millivolts or microvolts. I guess it's millivolts. Okay. And you see they're negative going pulses with relatively flat on the bottom. They're not perfectly flat, not as good as the other ones were, but they're much weaker than the other 360 degree wheel. Now I'm going to try to capture it right on the slot. Whoop, right there, right. And what's interesting, I got this set to DC. As you can see, it's going negative. It's going down. The voltage is dropping. I don't know if there's a bias voltage on or not. I don't think there is. I think it's pretty much zero to start with. So it goes a little bit negative. It's nowhere near the 20 millivolts. It's more like about 2 or 3 millivolts when I do that when I go slow. But when you spin it fast, I get about one full division, which is 20 millivolts. Okay, that's what I'm calling the questionable distributor. Now let's hook up Jeff's. Get this right now. The plus is on the outside. I'm using this one for the plus. Negative. Plus is on the outside. Negative. Now let's first notice the bias. Remember, I got this thing set at 0, or center point of the scale. And bias looks good. It's still in its approximate same spot, right at the center of the scale, so that didn't change. All right. Now, first of all, let's do a fast spin. Okay. I'm trying to get all this in so you can see everything. You can't see it very well here. I'm spinning the shaft pretty fast. It looks about the same. I mean, just eyeball. It's a negative going pulse. It looks like it's one full division. Oop, that was interesting. Now when I catch it on the halfway point, though, look, it jumps up. It goes positive on the upside, but the pulse when I spin fast is slow. I don't really understand what that means, but it's very interesting. Very slow, it goes positive. And it's 20 millivolts positive. And so it's got a positive bias when it goes up. So is the waveform actually much bigger? I don't know if I can get a better picture of that. Real fast. Let's go real fast. Okay, you see what's happening there? That's interesting though. For some reason, when it's on the space, it actually goes up about 20 millivolts and it comes back down. But the pulse that it generates when it spins fast is a negative going pulse. So that's something to do with the logic of the circuit. I don't know. Let's look at that one more time. So I'm going to swap these around. I'm just going to make sure I have it exactly the same. hooked up exactly the same. Fast spin, slow spin. Catch it? It goes negative. When I go slow, the bias actually drops. Let's go that really fast speed. Looks exactly the same. That's so strange. I wish I should understand what this meant. Well, anyway, the waveform appears very similar, nearly identical at normal operating speeds. Okay, you got a negative going, somewhat sawtoothy looking waveform. And I guess that's all that really matters. It doesn't really matter because the engine's doesn't spin over at, you know, like a clock, the hands of a clock. So from that perspective, they perform the same. The biases seem a little bit odd. I don't understand what's going on there. I'm going to perform the same test when I get the replacement crank angle sensor. In fact, I'll probably do that not installed on a distributor. I'm just curious what the raw output is. Remember I said something about taking a chopper wheel out. I don't know if I'm going to do that now because this pretty much says unless I have two identically bad distributors, then they appear the function, at least the output, the waveform looks the same. Does it stay the same when I get warm? I don't know. What I could do is I could just put Jeff's. I already put it in the engine run stand and tested Jeff's distributors firing and everything, the fuel pump and everything, just like mine. So there's no issue there. I'm going to turn this off. So the only real issue now is just put Jeff's distributor in and see if I can replicate the failure mode of just random total loss of spark. That's not that easy to accomplish because, last time it took 45 minutes. I guess I could just sit out there and let it idle all day and see if it does it. Another option, and this was again after talking to Jeff about it, is do I really have a problem with the crank angle sensors, since they seem to work perfect, and then just suddenly stop? Or is there an issue with the transistor mechanism that actually fires the coil? I mean, the way to do that would probably be to hook the scope up and see if the input signal coming out of the distributor or coming from the computer at the base of the transistor that fires the coil is going away when the problem happens. In order to check that out, though, I'd literally have to have the scope out there, hooked up to the base of the transmitter, and wait for it to happen. That is a way. That is a possibility. Because if the signal's still coming through the base of the transmitter, well, that would totally clear everything, the distributor and the ECU. So that might be a good point to try. Another thing that Jeff recommended is, he gave me this this transistor unit to test. Now it's pretty rough looking, so it's good to test it anyway. It's rusty. I mean, I'm sure it's just some general purpose. I think it's a NPN transistor. So if it's just a general purpose NPN transistor, I got a million of those, so that's not a problem. And it looks like this. I don't know if this is like. It looks like you can remove it. It looks like you can remove this transistor. So if the transistor is bad, I mean, this is kind of nice having this form because you've got the mount, the heat sink mount. You've got a place to mount the coil. All this is good. So this is kind of cool. So what I was thinking about doing, test this, see if it works. If it works, then what I'll do is I'll use a double throw. It doesn't have to be double throw, I guess, but a double pole switch. And what I can do with that double pole switch is I can switch out, let's say, the base and the emitter. Leave the collectors of the transistor connected. I think it goes to the ground. Is that how it works? Let's see. It goes to the collector connects to the. No, I'm sorry. The collector connects to the negative terminal of the coil, and grounds it through the emitter. Anyway, I can leave both collectors hooked up, and then I can just switch out the base and the emitter, from with the two poles, so I can toggle between two working switching units, the one I've got and this one. What I'll do first is while the motor's running, I'll just toggle it back and forth. Does the motor keep running? It probably have a brief miss, but if I can toggle, if I can set up a situation where I can have a switch, where I can switch out the transistors while it's running and everything works fine, well, okay, then I don't need to scope or anything like that. If it coughs or starts to die, or just dies and won't restart, click the switch, see if the other transmitter pops in and it starts working fine. So we can try that too. So two solutions. We can have a switch out the actual transistor, or get the scope out there and keep it permanently attached to the base of the transistor and look for a signal. Maybe both. Maybe we'll do both. I would sort of like to put the scope on the transistor just to look at the waveforms of what's going on, so I get a known good. I can look at the transistor base signal, and I can also look at the signals that are going into the ECU. I'm just shocked that's a 20 millivolt signal is all that's going to trigger the coil position, the spark position, those 60-degree divisions. That just seems shocking to me. Another test I did briefly was I compared the ohms, the resistance value of these two units. Like, for instance, this one here, I'm going to set it to ohms now. And this is kind of shocking. I didn't expect this. Isn't that funny? Shocking. Okay. Why does it say I have 300 ohms on a system that's completely dead shorted? I don't know why this thing's giving me 10 ohms when I got both these plugged in tight. Unless I've just got some, there we go, that's better. Okay, so what we're going to do now is I'm going to check the resistance of the sending poles. Okay, so I got, just in case there's a diode involved here, I put the positive lead to the ground, okay? The good lead, what I call the one in the high output, I get 102K, okay, 102,000 ohms. The low output one, I get 6 mega ohms. Is that right? Yeah, 6 meg. Okay, well that's not cool. What is this? Does that light it up? There you go. Well, that's kind of cool. I didn't know it had that function. Okay. So let's check. Is that the... That's mine. All right, now we're going to check Jeff's. All right, so we're going to go back to positive to the case, to the ground, and here we go. So the what I call the strong signal, 102K, right on the money, right? The weak signal, 5.92 meg. So again, a very high resistance reading on that. I think I checked. I also think I checked the. I don't think there's anything between ground and these. 5.8K. 0. That's interesting. So the negative lead is literally connected to the case. That's good to know. And so if we do that, we can see that we have a 5K on the LED side, the one that lights up. Now let's do that same test with the other unit. That's why I like having things that you can check against. Gives you an opportunity to compare. And it's not likely you'll have exactly the same failure. Okay, here we go again. So we're going to get, this should be the 5K, and this should be the 0. Okay, so these test exactly the same as far as resistance readings on the signal outs, resistance reading on the powers and ground. The waveform is slightly different. You could see the bias seems to be strange, where when one's turned off, the bias voltage goes up. When the other turns off, the bias voltage goes down. But when spun at a normal speed, you have approximately the same waveform, which is about a 20 millivolt downward spike. Some kind of sawtoothy looking on the bottom a little bit. But anyway, kind of a sawtooth shaped square wave, if you will. Both the high output ones, so I call the high output, the 360 degrees, looked identical. I don't remember. I'm not even worried about that because I don't think that's the issue here. I guess I should have checked about the biases and all that. But anyway, again, so I'm not sure what the best course of action is. I'll start with just swapping the distributor and just running that thing, just see what happens. If nothing else, it's a good test for Jeff's distributor, make sure it works. And one of the things I like about having the engine run stands, I can help buddies out, with testing their gear. So if they have any question about does it work or not, yeah, let's put it on the test stand and see what happens. But the follow-up to that will be to test the transistor unit, see if it works. If it does work, I'll probably do that double pole switch so I can switch out between the transistors. So if the problem recurs, I can quickly switch over, get the transistor to a new driver, and see if that makes any difference. Anyway, it's kind of a long video with a lot of talk. Hope this helps somebody out, and that's all for now. I'll keep updating as I find out new things. Thanks for watching. Bye.